Hello dear students, how are you? Dear students, today we will discuss about sigmatropic rearrangement. So, what is sigmatropic rearrangement? Let us see here. This is a type of pericyclic reaction, right? Sigmatropic word come from Greek word, right? Sigmatropic word come from Greek word in which sigma means sigma and tropos means change. It means in sigmatropic rearrangement there is a change of sigma bond, right? Sigmatropic reaction is a type of pericyclic reaction in which sigmatropic word come from Greek word which means sigma change, right? Sigma means sigma and tropos means change. In sigmatropic rearrangement there is change of sigma bond. Sigma bond shift from one position to the other, right? There is a rule for sigmatropic rearrangement. What is the rule? Let us see here. If electron pairs are odd in sigmatropic rearrangement, if electron pairs involved are odd, then superficial reaction is thermal and interfacial reaction is photochemical. If electron pairs involved are even, then superficial reaction is photochemical and interfacial reaction is thermal, right? If electron pairs involved in sigmatropic rearrangement are odd, then superficial reaction is thermally allowed and interfacial reaction is photochemically allowed. If electron pairs involved in sigmatropic reaction are even, then superficial reaction is photochemically allowed and interfacial reaction is thermally allowed, right? There are some important points for sigmatropic rearrangement. Let us see what are these important points. First point, we can say that we start numbering from the saturated atom on both sides, right? We start numbering from the saturated atom on both sides, that is both ends of old bond are numbered as 1, right? Then second point is sigma bond migrates to the end of pi bond or end of adjoining pi bond, right? Second point is sigma bond migrates to the end of pi bond or to the end of adjoining pi bond, right? Now let us take an example. as I mentioned in the start, that numbering starts from saturated atom on both sides. So this is saturated atom, means saturated bond. This is saturated bond and this is saturated atom. So we start numbering from saturated atom. 1 2 3. Similarly, in this case 1 2 3. We can say that we start numbering from allylic bond, both sides. This is allylic bond, right? We start numbering from allylic bond on both sides. This is allylic bond and we start numbering from this bond. 1 2 3, 1 2 3, right? Now what happens? This allylic bond migrates to the end of adjoining pi bond. This is adjoining pi bond. This is end of adjoining pi bond. This bond shift to this side, this bond shift to this side, and this bond shift to this side, right? And we get this product, right? Now in this case, one electron pair, two electron pairs, three electron pairs, right? These three electron pairs involved in the reaction, right? This bond shift to this side means electron pair involved in reaction. This bond shift to this side means electron pair involved in reaction. This bond shift to this side means electron pair involved in reaction. Odd number of electron pairs are there in the reaction. 3 electron pairs are there, right? So if there are odd number of electron pairs involved in the reaction, then reaction is thermally allowed, right? Another important point is there, if new bond formed between A and B. Suppose new bond formed in sigmatropic reaction is between A and B, then we can say that A comma B sigmatropic rearrangement, right? In this case, new bond is formed between this third carbon atom and this third carbon atom. So this reaction is 3 comma 3 sigmatropic rearrangement, right? This reaction proceed to transition state. So let us see what is transition state. We can write this structure like this. This structure is same as this structure. We can write this structure like this also. So in this case, what happens? This bond shift to this side, this bond shift to this side, and this bond shift to this side, right? We get product like this. When this compound is heated, we get this structure, right? This bond shift to this side and new bond is formed in this case. This bond shift to this side, new bond is formed here, and this bond shift to this side, new bond is formed here, right? So this structure formed pass through transition state. In transition state, we put dots for new bond as well as old bond, right? So in this case, this is old bond, so we put dots for old bond, and this bond shift to this side means new bond formed. We put dots for this new bond. Then this is old bond, we put dot for this old bond. Then new bond formed, this one, we put dot for this new bond. This is old bond, we put dot for this old bond. And this is new bond, we put dot for this new bond. So this is transition state, right? This structure passes through transition state and we get final product, right? In transition state, we put dots for old bond as well as for new bond, right? In this reaction, sigma bond shift to end of adjoining pi bond, right? I once again repeat, in this reaction, sigma bond shift to end of adjoining pi bond. Now we take another example in which sigma bond shift to end of pi bond, right? This is another example, right? In this case, this is allylic bond, so this bond shift or this bond migrate, right? Now what happens? This bond shift to this side, means this sigma bond shift to end of pi bond, right? And this bond shift to this side, so we get products like this, right? Or we can write this product like this. So this was all about sigmatropic rearrangement.